So welcome everybody to this second webinar on of this summer webinar series. This time we'll be having the topic on occupational exoskeleton with three very important speakers. We will touch a different aspect of this rapidly growing field of industrial exoskeleton. We will be talking around 1 hour and a half. People, the three invited speakers will be given a talk on 20 minutes each, and then we will start a roundtable of approximately 30 minutes. Before starting, I would like to make a brief introduction and first welcome all the attendees, of course, thanking the three speakers that are staying with us today. And most of all, also welcome all the member of the Cost Action. You know, this summer webinar series is a joint event organized in collaboration between the Cost Action on Wearable Robots, which is chaired by Jan Venneman, that cannot stay here today, and also the EUROBENCH Project, which is coordinated by myself. And I will provide just a brief intro on these two projects because for some people may not know them, and so it's good for you to know. So the Cost Action on Wearable Robot is a European initiative. It's a network of experts in the field of, in this case, of wearable robots all around Europe. And the objective is to integrate and develop all kinds of expertise, a multidisciplinary expertise from people in this field, and in order to realize a new generation of wearable robots with better adjustment to human user, and also to better fit with the specific domains of application. And we have done a lot of activity. This year actually is the last year. In September 15, this network will stop, and then we will have to find new ways of staying together in this difficult situation. So these webinars are also a way to gather people, continue gathering people in this endeavor. And the project EUROBENCH is a European project whose aim is to develop the first framework for benchmarking and testing of different kind of bipedal locomotion technologies, among them exoskeleton. So we have here, for example, Jawad Masood, which is one of these sub-projects that have been funded by EUROBENCH to develop a new benchmarking test method. He will be talking about this. And actually, this is also EUROBENCH project also is a kind of effort to put together also a network of people. Apart from the consortium, we are involved in more than 60 other entities in Europe and worldwide also to contribute to this new test method, to new standards. And so we think that together with COST and EUROBENCH will be more than 100 entities in Europe. And this for us is very important because we want really to push forward all the effort and multidisciplinary effort in the field of wearable robots. So, as you may know, this summer webinar series is made of 4 different webinars. We are already at the second one. So the first was on educational exoskeleton. This is about occupational exoskeleton. The next one at the end of August will be on medical systems, and the last one in September will be on standardization and benchmarking. Okay, without wait any further, just some logistics. You know, there are 3 talks, but the question will be, so we ask you to write all your question in the chat, and then I will pick the most relevant or the ones that are more common among the attendees, and then we'll post this question to the speaker at the end during the roundtable starting at 11. Okay, so I think we can start with the first speaker, which is Saskia Baltrusch. unfortunately, she cannot stay here in person, so she prepared a video. So we will put her video on top, but she will in the roundtable. She will participate in the roundtable, so you can also pose any question to her. A brief introduction to Saskia. Saskia is working as a research scientist at TNO in the Department of Sustainable Productivity and Employability. And current projects are focused on accelerating the adoption of exoskeleton into industry and also on improving human-robot interaction to improve the effect on job quality. Saskia obtained her PhD at the Vrije University of Amsterdam in 2020. So she is a postdoc for 1 year. And during the 4 years, she has been working in the development and evaluation of passive trunk exoskeleton for low back pain prevention. And so without waiting more, so Carbinia can share the screen and put the video on.
Yeah, welcome everybody to my presentation for the summer webinar, and thanks for inviting me today. I will talk about the importance of a user-centered approach when designing an exoskeleton today, and also the challenge when implementing an exoskeleton in the work field. As a short introduction, for people who don't know me or my name, I'm Saskia Baltrusch, and I did my bachelor's in Germany in sports sciences, and then decided to go abroad and did 1 year master in human movement sciences in Amsterdam. And after that, I decided to stay in Amsterdam and wanted to get more knowledge in human movement sciences and also more experience in research, and started my PhD in human movement sciences. And during my PhD, I was part in the SPEXOR Project, which was a project that had the aim to develop and evaluate a back exoskeleton for low back pain prevention and vocational reintegration. So I will talk a lot about that research that I've done in these 4 years today, but I will also talk about some work experience I've collected in the last year, because now I'm a researcher and scientist innovator at TNO. That's a Center for Applied Research. So we're closer to the field now, and we're still doing a lot of projects on exoskeleton implementation as well. This is my thesis that I wrote within the SPEXOR Project, Lifting Success of Trunk Exoskeletons. And I wanted to show how we can bridge the gap between biomechanical solutions, so in this case in exoskeletons, and end users' perceptions. So how can an user-centered approach support us in designing an optimal exoskeleton for the end user? I would like to start with a use case here, which is a luggage handler at an airline company. What they basically have to do is load these suitcases from the belt onto the carts or the other way around, and that for 8 hours a day. So a lot of people within this company developed low back pain in the last couple of years. And the company is aware of that, and that's why they already implemented automated processes, but also a couple of lifting devices. This is one example. This is a robot. I think they have like 3 standing in their working environment there. And what it does, it basically scans the dimension of the suitcases. It has like cameras on this metal plate. Then it picks up the suitcase, and it scans the container, looks where there's space, and then it puts the suitcase wherever there's space in this container. One problem about this, as you can maybe already see, is that it's super slow. So it's not really effective. Manual work could actually be faster, but they can't increase the speed because then apparently there are a lot of problems coming up. And because also the robot makes mistakes, sometimes a person still has to manually correct that. So it's not really efficient. Then they have 2 other lifting devices hanging everywhere in the holes. On the left side, you see one that works with air pressure. So you suck up the suitcase and then you release it again. Or a lifting table. You can adjust that in height, and then you just pull the suitcase on it, and then you pull it off again. The problem about these ones is that they hang everywhere in the halls, and they're available for everyone, but nobody really uses them. And when you ask the employees, they say the lifting device is good, but it's slow. Manual work is faster, and it's hindering more than it is helping. Well, and this is a perfect use case to basically show that not the first step that you should normally do, adapting the working environment and look how you can help people by adapting the working environment to unload their bag, is not always the best solution, as it might not be efficient or people might not use the implemented devices. And in that case, you can use an exoskeleton. The question now is, how can we design an exoskeleton that is good for this use case? In the SPEXOR project, we took a user-centered approach, and I would like to show you why this is really important to do that. We started with benchmarking, so testing exoskeletons that were already on the market, and we started with discussion rounds, focus groups with potential end users, so not only luggage handlers, but also low back pain patients and healthcare professionals. And we asked them about their view, what kind of worries do you have about using exoskeletons, or where do you have wishes for the design of the exoskeleton, things like that. Then we developed the exoskeleton. Then we did an iterative testing with the people from the airline company. And after that, we had again discussion rounds with the same people and their managers. And I'm just going to go through some examples how the input from the end users helped us in designing the exoskeleton, but also in how we studied the exoskeleton. The first example is that one of the people in the discussion said, I would like to have like a button on the exoskeletons that you can switch between on and off, so that you can basically switch on and off the support. Because in certain movements, I might not want to have the support, and in other movements, I do want to have it. And that was interesting because when we did the benchmark tests, we had similar results. In the benchmarking, we tested a Laevo device, and we basically asked the participants to perform a set of working tasks, so that tasks that you can think of in a daily working environment. And they had to do that once with and once without the exoskeleton. And then we asked them to state whether they felt supported or hindered by the exoskeleton. And the green boxes show in which they felt supported, which was only one task, static forward bending. And the red boxes stand for the tasks in which they felt hindered. So they felt hindered in a lot of tasks. And that was mainly because they were working against the support of the exoskeleton. So that basically also gave us the result of, okay, if we design our own exoskeleton, we need the possibility to disengage the device, which was in line with what the end users said, potential end users. So we did that. This was the exoskeleton design. We had two components, the carbon beams on the back and the springs on the side on the thighs. The carbon beams were for supporting the trunk flexion, and the springs on the side of the thighs for supporting the hip flexion. And they both release energy if you go down, and save energy when you go down, and release that energy when you come up again. And then we implemented a clutch system, which has a little lever arm that you can pull up and down, and by that disengaging the springs on the thighs. So you basically disengage the support for the hip flexion, which makes people be able to just walk around without constantly working against the support of the device or the resistance of the device. So we did then the same test again, as we wanted to know, well, did they change anything? And the first thing you see is, so here in the bottom, you see the new results. There's a clutch system. There are no red boxes anymore. So people did not feel hindered anymore in any of these tasks. So the clutch system actually worked, which shows the importance of having a switch on-off button basically for an exoskeleton. Another example was that a lot of people, whether it were back pain patients, healthcare professionals, or also the employees, they always said, if you don't use your back muscles the whole day because you're wearing the exoskeleton, then the muscles get weak, right? And that's a big concern from potential end users. And so we decided to measure the effect on muscle activity when wearing an exoskeleton. And we also measured the effect on metabolic health, so oxygen consumption, to show an additional parameter that can show whether you get support by the exoskeleton or not. So we invited people to the lab from the luggage handlers, and they had to do a lifting task for 5 minutes with and without the exoskeleton. And we saw that when they were wearing the exoskeleton, the oxygen consumption decreased by 18%. And that already showed that there is a support by the exoskeleton. The muscle activity also decreased by 10 to 16% when wearing the exoskeleton. And as you can see, it's 10 to 16%, so it means your muscles still do quite an amount of work. So over a longer period of time, you don't expect the muscles to get weak. To really know that, of course, you have to do a longer study. But what we learned from that is that you should always use an exoskeleton temporarily, and you should have an adjustable support. So people can decide whether they want to have 20% support, whether they want to have the full support, or maybe only 50% support based on the task they want to be supported. Two other statements that I put on one slide here is one came from the healthcare professionals, that they were afraid that people might get dependent on the exoskeleton and lose their confidence in their own body. And the managers were talking about implementation strategies and whether an exoskeleton should be obligated to protect people against themselves. Why I put them here on the same slide is that I think both of these statements basically show that when implementing an exoskeleton, what really matters is communication. How do you communicate the implementation of an exoskeleton can really influence the acceptance of the exoskeleton. So lessons learned from this research are an exoskeleton can potentially prevent from low back pain. The optimal design of an exoskeleton is context dependent. So if you measure it in one context, doesn't mean that it's going to be the same effect in another context. And user-centered approach is important to aim for optimal exoskeleton design that really is for the specific needs of the user. And it is important to have an adequate implementation strategy. Well, and the last point basically brings me to the work that I'm doing now at TNO, because there we're closer to the field, and we're also doing field testing as exoskeletons towards do companies really want to implement exoskeletons? And there are quite a lot of challenges. One main challenge is that a lot of companies, for example, are not even aware of exoskeletons, especially the small companies. They don't even know that exoskeletons exist, let's say, or that there are potential solutions. Yeah, and that brings me to a project that we're doing currently at TNO. It's a big European research project within the North Sea region with a lot of international partners. It's called Accelerate. And the objective of that project is to accelerate the adoption of exoskeletons into construction and industrial manufacturing. And the methods we're using is that basically every partner in the region comes up with ideas for workshops to reach that goal. And we had a big workshop last month, actually, called Exhibition and Talk. And the goals of this specific workshop was to connect exoskeleton developers with companies interested in exoskeletons. So we invited about 15 companies that were interested in exoskeletons or also had some experience with it already. And we also invited a wide range of exoskeleton developers. And we wanted to identify challenges and barriers for implementation of exoskeletons from the company's perspective. And we also wanted to share our knowledge on potential benefits of exoskeletons in industry. These were the exoskeleton developers that we invited. So we had shoulder exoskeletons, we had back exoskeletons, rigid back exoskeleton, and also soft back exoskeletons. They were all passive, but we also had one active back exoskeleton, the Cray X from German Bionics. So we had a nice range of the most important international exoskeletons that are on the market. The program of the exhibition and talk was that we had a short welcome, then the companies introduced themselves, then every exoskeleton developer could have a 2-minute pitch so that everyone knew what kind of exoskeleton developers are there. And then we had a 2 hours open floor exhibition where people could just walk around, get in conversation with the exoskeleton developers, try on exoskeletons, ask questions, things like that. So to really get people connected with the exoskeleton developers. And after that, we split the groups into arm and back exoskeleton groups. And then we had discussions on use cases And also, so for example, we ask each company for a specific use case they could think of where they might see a potential for implementing an exoskeleton, and we discussed about that. And we also asked them about positive and negative experience with exoskeletons. And then we had a closing. I will come back to the results a little bit later because I want to combine that with results from another study that we did. So another study that we're currently busy with, which is also really important to do in my opinion, and that is not happening enough yet, but I hope it's going to come in the future, is real field studies over a longer period of time. Because we now know that exoskeletons can be effective preventing people from, or supporting them doing their work, unloading their back or unloading their shoulders. But we do not know whether people will also accept the exoskeleton over a longer period of time. What if somebody takes an exoskeleton into a working environment for like half a year? Are they still using it after half a year, or do they just throw it away and say, no, sorry, that's nothing for me? And we wanted to we started one of these field studies with plasterers. And our objectives in the study was that we wanted to address the preconditions for successful implementation, and we wanted to address the effects on workload. And therefore, we gave 45 plasterers a shoulder exoskeleton, the Skelex, and they were able to use this exoskeleton for 6 weeks during their work. The study setup was that we first had a kickoff. We explained the whole study setup and the questionnaires that they had to fill in. Then we had a fitting session, so everyone got their own exoskeleton that they would work with, and we adjusted them to their body. Then they were working 1 week without the exoskeleton, kind of as a base measurement, and then they worked 6 weeks with the exoskeleton. And we, after week 3 and after week 5, we called in and asked, yeah, how do you feel about working with the exoskeleton, and what is good, what is not good, things like that. And we sent a daily questionnaire asking them about, for example, this is in Dutch now, but it says, what did you do this day in your work, and how long did you do that? And then they would fill that in, and a follow-up question would be, did you use the exoskeleton during that task or not? So to see, is there maybe a shift in task that they use the exoskeleton or that they don't? Another potential question could be, or was, that we asked them to say how much discomfort they have in certain body areas. As I said, this study is still running, so I can't really show you results yet. I can only show you preliminary results of the talks we had with them doing the interviews on the phone. So what you could see was that in the first weeks, they were still trying out a lot of tasks, giving every task a chance, and just to see whether the exoskeleton could be of a potential support or not. And then in the last weeks, you saw that there was a shift towards a selection of tasks, so that they said, yeah, doing ceiling work, it's really nice, but doing wall work, it's less nice. That's also a bit what we expected, and it was nice to hear that already. Then you hear a lot that you really have to get used to it. And for some people, it's really challenging. There was one person who said, I feel like I'm locked up in this thing, because he's been working as a plasterer for 25 years already, and now all of a sudden you have to work with a device. And then the exoskeleton takes in a lot of space, they say, even though the Skelex is already quite an exoskeleton that doesn't stick out that much. But still, if you work in small rooms, it's a problem. And sweating was a big problem. We had one group that was really working in the heat, and then it leads to skin irritation if you start sweating. And another point was that the exoskeleton gets really dirty. So this is an exoskeleton after 6 weeks, and we really had to clean them a lot. So I wonder how they look like if somebody uses that for 6 months. So main challenges based on this work that I do at TNO. Number one, an exoskeleton is not the #1 solution. So when you if you want to implement an exoskeleton, first think about other solutions that might be possible. And a lot of companies don't do that, and we always have to remind them of that. The second one, acceptance by the end user, is dependent on the use case itself and also on the individual employee. So you can't, like, for one employee it might work, for another one it might not work, which is also a challenge. Then there's often a high variety of tasks and postures at work. So normally exoskeletons are good for repetitive work and you always do the same movement again and again. But there are not a lot of jobs where you see these repetitive movements. Even if you think for some jobs that's the case, it's still not. And then it's really complicated to think of how can I implement an exoskeleton then. And I think, in my opinion, an exoskeleton is probably going to be more of a tool for certain tasks that can be used for maybe an hour when you do something, and then you put it aside again instead of using it for your whole job. The fourth one, be aware of your goal. Because do you want to reach a better health of the employee? Do you want to reach better productivity? Based on your goal, your implementation strategy is also going to be different. And another challenge is that you always need good instructions and actually a long-term training so that people really know how they use this exoskeleton and use it in the right way. But this long-term training is also hard to implement during work. So that was it from my side. I hope you enjoyed it. Sorry that I couldn't be there in live, but you will see me during the discussion round. Thanks for your attention.
So thank you, Saskia, even if you cannot hear us. It was like having you here with us. Anyway, we will have air in the round table. I know there is already some question. That's good. To someone broke the ice. I will suppose some of them, but please write all the questions. So in the meantime, speaker can even try to answer already, as Boudewijn already did, or we treat them afterwards. So let me introduce the second speaker, which is Jawad Masood. Jawad is mechanical engineering with a PhD in robotics. He is the team leader in the applied wearable and human-in-the-loop robotics here in Spain at Automotive Technology Center of Galicia, CETAG. His research is focused on seeking objective and subjective evidence that exoskeleton and exosuit are beneficial for industrial applications. He's also an awardee from EUROBENCH Project, so he is developing these test methods for exoskeleton in industrial application, and this will be the topic of his talk today. So please, Jawad, the floor is yours.
Thank you very much, Diego. I'm going to share my screen. Please confirm me if you can see it.
Yes.
Okay, and can you hear me well as well?
Also.
Okay, so hello everyone. Thank you very much, Diego, for a nice introduction. It is my pleasure to talk today on the benchmarking of occupational exoskeletons and also share with you some of our experiences while developing a tested project, which is part of the EUROBENCH initiative. So to get started, I would like to introduce my from where I am coming from. I work at CTAG, Automotive Technology Center of Galicia. We are a private research and technology organization in the northwest part of Spain. We are more than 700 people. We provide research and development innovation services. We main focus on the automotive domain. However, the construction, logistics, and agricultural domain are also part of our focus. The main technology areas which we basically focus are processes and industry 4.0, product design and simulation, validation and testing of the automotive vehicles, development of new materials, electronics and intelligent transport systems, and passive safety. And I comes from the processes and industry 4.0 area. So in our lab, one interesting infrastructure to discuss is the process lab, which is process lab 4.0. It is a pilot manufacturing line which can work with the automotive, real automotive line speeds. Basically, this is developed for the pre-industrialization of the emerging technologies. We would like to use also, for example, this one as exoskeleton and for the testing of exoskeleton and the human in the loop projects. So after this introduction, I would like to first explain about what are the main challenges to the benchmarking of the exoskeletons, and also, for example, from there on, I would introduce you with the tested project. So today, manual handling task in industry is a very big concern. 3 out of every 5 EU28 area workers report the MST complaints. Among these workers, 60% actually identify the MST or out of all total health problems they suffer. And 1 out of 5 people which basically suffer the chronic back and neck disorder in the past year. This is the data from 2019. So Spain is not an exception. I am working in Spain, and basically it's one of the main area I am working on. And musculoskeletal disorder caused by repetitive motion or overexertions are on rise in Spain. It is 16% increase from 2018 as compared in 2019. So this call of a solution to help the industrial workers specifically to mitigate this sort of disorders. And in industry, is not look like how we see in the lab. Industry have several different type of use cases, even though for a similar one use case, there can be a product which is different, and the use case actually with the similar condition, the tooling and, for example, processes may change. So here I am giving you an example of confined use cases taken from the 3 different industries. The left bottom side, you can see the use case taken from the automotive industry. On the top right side is taken from the aeronautical, and the bottom is taken from the construction. So as you can see, more or less the posters are very close. However, they are in a very different environments. And this is also one interesting and very challenging task for example, development for the wearable robotics. So to keep up to this type of tasks, there are 2 ways, for instance, which we can look for. One is, for example, cognitive assistance, which comes with the development of information systems or using artificial intelligence and prediction. Or we can go through the physical assistance, which involves the manipulators, for example, hand manipulators or exoskeletons or exosuits. And then here, for example, is a very important part, as we mentioned, that not all the problems can be solved by exoskeleton or wearable robotics. There are many other solutions which can be considered for example, solving of a problem. So in this study or in this presentation, I will mainly focus on the exoskeletons and exosuits as a main component, assuming that this is one of the technology which can help. So occupational exoskeleton technologies, we have write a paper in 2019 where we identified 45 commercial industrial exoskeleton manufacturers and the 30 commercial research exoskeleton manufacturers. And 2019-2020 market says 110 million USDs as a market size of exoskeleton. It includes the healthcare exoskeletons as well. And for the next 5 years, there is 56.3% CAGR compound annual growth rate projection, which means that this technology in the coming years is going to be evolving, it's going to be adopted even more. So in this case, it require a very good solution for the testing. So in the market, we have a diverse exoskeletons and exosuit types. For example, they can exist in passive, active, quasi-passive or quasi-active types. And more than this, they are also very specific to the body type as well. For instance, they can be focused mainly on to the arm and the neck support, or the hand support, or on the back support or the leg support. So there are very diverse type of exoskeletons, and testing of this type of exoskeletons, which are very different, is also a very, very challenging task. As well as, for example, coming to this point, if we will see into the industry, we have a different testing processes as well, which actually can use to test this type of tasks. One of this testing process is a 4-phase testing process, which start from the selection, then test lab and simulation and inline. However, other people can also work with the testing process where we can start with the inline subjective implementation at the same time. So it is a bit ambiguous at this moment that which testing process people should follow. So there is a need, for example, to look for a benchmark process which can help testing the wearable exoskeletons. So putting everything together, we see that there is a diversity challenge on the human side, there on the industrial exoskeleton use case side, on the exoskeleton technology as a whole, as well as on the testing processes. And all of these together what a big challenge, as well as it is very interesting to look at. So in 2019, we actually put all a few of these challenges, like, for example, putting the link different use cases together, or deficiency of long-term impact, long-term time and cost, and the lack of business models for testing certification for exoskeletons. And then we propose a project called Tested, where we would like to connect 3 of the industrial use cases to the narrow space testbed. And we also propose to work with 5 local indicators such as impact, usability, utility, safety, and relevance. And then we thought that with this project we can actually reduce 30% in the testing time and cost. And overall we thought to implement this to add the CSIC facilities. With this, I would like to now switch towards the technology which we have developed for the last 2 years. And I start with the specifications of our testbed which we have developed so far. So here you can see on your right hand side a testbed 3D model. On the top side is CAD model, and on the bottom you can see the picture of the testbed. So this testbed is basically consists of the transparent walls made of the polycarbonate and of 30 millimeter thickness, and the main aim is to use them for example, motion capture systems or other measurement devices which are infrastructure based, and also for the monitoring of the subject within the testbed. The floor is made up of wood. It is basically the floor width could be variable with the help of the actuators. You can actually have the maximum width of 1500 millimeters. The wall height is 1500 millimeters. The length, for example, can be variable and can reach up to 4500 millimeters. The structure of the sports surface can be divided into 1500 millimeter into 1500 millimeters to allow the storage. There are developed telescopic hurdles in order to constrain the workspace. The testbed is motorized. And lastly, that it is have all the hurdles and the walls which are on the middle of the testbeds are force sensitive. So on the mechatronic side, we have 2 actuators which actually can move the middle module, and then we have a stroke length of 1000 millimeters. We can reach up to minimum to 4 meter per minute to maximum 40 meter per minute of the velocity with the frequency of 50 hertz and power of 0.37. So these are basic specifications of the actuators. Then on the sensor side, we have the load cells integrated into the middle module, where we have this compression tension 100 kilogram load cells. We have for the entry and exit of the test bed the photoelectric detectors. For the measurement of the distance between the wall, we use the laser distance sensors, and we have the limit switch for the motors as well. So all of the communication is via the PLC, programmable logic controller. So for the force sensitive walls, we have basically a linear force measurement. Each movable module contains a single load cell, and the fixed wall contains the 3 load cells as well on the opposite side. And we would like to also have to mention that some of the other part of the module 1 and module 3, we use the accelerometer instead of the walls load cells. So all these testbed can be configured as a modular structure. So the length can be adjustable as well. So you can use as setup 1 as single module, or setup 2 or setup 3. So actually you can change the length according to your desired use case. Or for example, you can also adjust the width, that is the distance between the walls. And I would like to show you a video where you can okay. Okay, so you have seen how the walls can be moved in order to have a configuration closer to the use case. Then there are the 3 modules consisting of the wheel for quick assembly. So in addition to the hardware, in this project, we have also worked on the software routines. We have developed 7 performance indicators, in which, for instance, we work with 5 objective methods: chrono analysis, heart rate monitoring, metabolic cost, and range of motion and balance. And 2 subjective methods, which are questionnaires, interviews, and the board scale. So here, for example, on the next column, you can see the reference metrics, which we basically measure with these performance metrics. And in the last column, you can see the linked local performances, which we have connected with these performances. All of these performance metrics are the open source software, which you can actually check or access on the GitHub. We are planning from 30th of August to go to C6 facilities to have a verification of these performance indicators as well. So coming back to the main question, which is basically also about the benchmarking of occupational exoskeleton and how basically this all these puzzles can connect together. I think that would be very important part, and I would like to start with a conceptual model of the benchmarking process, which basically we have I have also explained into the KPIs. So in this case, for example, we would like to start with the selection of materials. For example, what use case we would like to do, what exoskeleton we would like to choose, what performance indicators or evaluation criteria we would like to have, what would be the the participant sample size, gender balance, and participation experience, and these aspects. What would be the hardware, for example, which test bed we should use, which devices we should have for the corresponding performance indicators, what software we should use in this case, for example, if we use the EUROBENCH software, or what firmware, other firmware which we can use for the performance indicators, and what are the main protocols which we can use for the benchmarking. And in the second phase, once we have selected these all components, we can go to the benchmarking, where basically we can go physically to the facilities and perform the testing, and where we have the material preparation, data collection, and data analysis. I would like to explain this into more detail with one example. So for the audience, you can learn a little more about that. So for example, let's assume that XYZ company is an aeronautical company who have use case, and then this use case, they would like to deploy an exoskeleton such as Laevo Exoskeletons Nuni, and they have, for example, this use case, and they contact Nuni and they would like to benchmark and check if, for example, for this specific use case, it would be worth to have the investment. So in this case, for example, they have the use case details. There is a stakeholder also, for example, here we can see identify two main stakeholders. One is the use case provider, and the other, the exoskeleton technology provider. And then as we see here that we have the use case as we select as a confined spaces, we have an exoskeleton, which is, for example, Laevo exoskeleton. The more important part in this case would be to see what would be the configuration of this exoskeleton. Then the performance indicators. For instance, let's imagine that we would like to see the task completion time. Then what would be the participant sample size and the experience, what would be the hardware we would like to use. Okay, so this will be the first things which we actually select. For example, for the hardware we can use testbed and tested. For the software, we can use a benchmarking application, which is the EUROBENCH software. And then the protocol, which type of protocol you like to use. For example, on the device placement, or it is an absolute type where we are comparing our values with the benchmark, or it's a relative type that we are comparing with or without an exoskeleton. So after the selection, we can actually go to the benchmarking phase, where the first part would be the testbed configuration. Then we ask the subjects to do the consent, which basically either could be digital or with the help of the paper. We can also then put the devices. The first then would be the protocol verification, and then one important aspect is the familiarization of the use case as well as with the device. And after this, there would be the protocol execution, the raw data collection, and data pre-processing. And this pre-processed data would be fed into the PI algorithm, which could be in the C6 software. And finally, there would be a benchmarking score on which basically the end user could decide either it will like to go to the inline testing or not. So with this, I would like to come to the last part, which is basically the main lesson learned during the tested project. I think the first one is the scalability. We would like to think that how different type of use cases, for example, which are outside the specifications, could be scalable and adjusted to the tested. What are the reproducibility aspects benchmarking can bring forward? For example, the standardized protocols, the standardized benchmarks, and the standardized sample sizes and gender balance. What are the stakeholder involvement? For example, the concerns about the product information, the use case information, and how that information kept secret, for example, in this case, and not be shared either via some NDA or some other measures. this is a very important part. Then the familiarization part about the use case and exoskeleton, what benchmarking actually bring forward. Did they, for example, say 2 hours familiarization, 10 hours, 5 days? So this is something which basically benchmarking could provide more. And data protection, I think GDPR is very good, but we still need, for example, other type of data protection, for example, synthesized data or other important part, that how basically we will save the data. And at the last, I think it could be very interesting to look for a unique score, not only like different scores, but only one benchmarking score which actually can highlight the importance of the exoskeleton performance. With this, I would like to direct you to some of the, if you have like to explore more information on the mechanical end, we have a patent which is in Spanish, but you can still access. It's approved. The article is for the IS system, information system. We have with Diego and the team, we have also worked with one standard where we actually see that how different performance indicators can go and make a standard. So I think it's a good link to CEN CWS 1110. And then there is an upcoming talk on benchmarking and assessment on the wearable Veracon Europe 2021 on October 5th between 11 and 12. With this, I would like to thank everyone, and if I would be glad to answer your questions. And this is our teamwork with all the team members here, and I would like to acknowledge it for to all the team members. Thank you very much.
Thank you very much, Jawad, for the very interesting presentation. There are some questions, so let's just let this for the end. And let me introduce the last speaker, which is Boudewijn Wisse, very well known in this field because he's one of the pioneers in this kind of technology, on the back support exoskeleton. He's an industrial design engineer by education, and then now entrepreneur during some years. And his main goal is to develop this new type of exoskeleton and make this really meet users' need in several applications. And today I will talk about piloting and deploying occupational exoskeleton in practice. Please, Boudewijn.
Yes, thank you for having me, and thank you for the great two presentations that we already saw. I'm going to try to tell another story from the side of the exo manufacturer and what we see in practice. So I assume you all can see my presentation. Perfect.
Yes.
So first about us, we started working on exoskeletons in 2010 from a research perspective. Later we founded our company, and currently we are selling our exoskeleton worldwide. During all this work, of course, I often go to customers to see how our exoskeleton is used in practice. So here you see me with a surgeon that is trying the exoskeleton for the first time. Just a picture to show that we are trying to do a lot of work in a lot of different fields just to see where the application of the exoskeleton can be. So that's a lot of experimentation is also involved. So what we want to do is we want to support every worker, every task, every industry. So this is a very high goal, of course, because as we've seen in the previous presentations, it's very challenging to make something that is fit for every task. And actually, it's not possible. But we can strive because it's very difficult for people who want to apply the exoskeleton to know on forehand where is this exoskeleton good for me and for our workers. So I'll be talking about that especially later in the presentation. Yeah. So this is our exoskeleton. For who doesn't know it, it's a 2.5 back exoskeleton. We have a hip support based also on a spring system. We have a chest support, and it's also, as Saskia has told in the presentation, you can switch it on and off, and you can also set to some extent the support angle that you wish to be supported in. I think it's we focus a lot on making a product that's actually usable in practice. So it's very affordable. It's also reliable. So we always test our products to be able to withstand more than 250,000 full bench cycles, just to make sure that you can work for many years with the product. So what's the intended use of our product? For us, it's to reduce the backload of workers. And that's a very broad application area. We always say that it's only meant for people that are doing the static posture for a long time or repetitive lifting, but it's not meant to provide superhuman powers and to start lifting heavier stuff. So setting the expectation what the exoskeleton can do for the end user and for the customer is very important. Our main application area is industry and logistics, but we also have some customers, for example, in agriculture or in defense or in healthcare. So this is something that Saskia also stressed. Basically, there are two main use factors why customers are looking into exoskeletons. It's either to promote health of their workers or to promote productivity and to improve productivity. And it really makes it a large difference of how the exoskeleton is going to be evaluated and how the exoskeleton is going to be used in what context. For example, for health, it's a big difference if you want to cure people, reintegrate them into the work. Just use the exoskeletons for people that already have back pain in our case, or if you want to provide the exoskeleton to a whole team that's doing tasks that are challenging and possibly damaging. And this makes it just makes it a very wide and confused area where there's all kinds of different aspects to be taken into account, which makes basically that all customers or all implementers in the end are going to try and use the exoskeleton, whatever exoskeleton it is, because every user and every customer is different. So basically here in the left column, you'll see that what you see on websites, the approach that you see is that exo manufacturers, they provide a demo day or come by to customers that want to implement exoskeletons. If they see that it's sensible to do so, then often an experience or a pilot is offered. And if the pilot is successful, then there will be deployment. From a research perspective, in the middle column, often first lab tests are done for example, EMG tests, as in the bench test bed that we just saw. And then, of course, we need to test it in the field and in the end, make sure that in the implementation, long-term effects are monitored and the use is also monitored. So we have a lot of different tools to do so, from observations to sensoring. And actually, just in the beginning, when people are introduced to the exoskeleton, it's important to see if there are direct benefits for the end user, and there is this willingness to try the product. With all exoskeletons, the effect is only valid if you are got used to it. So it's also very difficult to do lab studies to that extent, because often lab studies are done with subjects that didn't train with the exoskeleton. And from a metabolic perspective, but also just from getting used to and also the mental load of the exoskeleton, it's very important to have a long time use of the exoskeleton. I often compare it to putting new people on the bike for the first time and say, go bike, and then measure if they can make 80 kilometers of distance on the bike. No, they cannot, because they first have to learn how to work the bike. So the same as with the exoskeletons, just change just a little bit this proprioception and other aspects of the motor control So you have to get used to it, and that's also something that we guide our clients with. So how do we see the roles there? So we have our own role as the manufacturers at the left side, but also as an industry as a whole. So all the manufacturers together. And we've already heard some standards that are being developed from, for example, from European perspectives, such as the CEN, but also the Americans are working on in the ASTM on the work group F48. For now 2 or 3 years, and this F48.02 is specifically about human factors and the evaluation of the exoskeletons in practice. Then we have the implementer. That is the party that is going to make sure that the exoskeleton is used on the work floor. Sometimes that is the manufacturer themselves, the exoskeleton manufacturer, but also often it's, for example, the health and safety officer within the company. And in the end, of course, at the right side, we have the end user. There can be many different use cases. That is really, in the end, the one that will make or break the product and will determine the success. So there's a lot of information flow going on to make a success from this, from the industry to the implementer, from the implementer to the end user. As a manufacturer, we train the trainer, so we train the trainer to the implementers. Just sort of really a whole ecosystem going on here. But because exoskeletons are very new, it's all fresh and in development. So what is the guidance that we should provide as a manufacturer, as the industry as a whole, but also as the scientists? And it's something that, for example, from the Accelerate project is starting to happen in a more structured way. But basically, we first have to see when to consider exoskeletons. Is it sensible to use an exoskeleton, or is there, for example, another tool that is better for this work situation? Then we should provide how to test the exoskeleton, what is a sensible way to look at it, how to deploy it, and in the end, how to maintain it, use it, and monitor the effects over a long time. Directly to the end user, of course, there is this instructions for use, which is also legally obliged from, for example, a CE perspective, in which there's the manual, for example, that gives insight in when to use it, is the sizing correct, is the exoskeleton safe, can I wash it, etc., etc. So many requirements there. So how is our approach to that communications lines? Well, of course, we do first workplace visits and just see if it's sensible to use the exoskeleton or if there are better ways to provide health and safety for the end users. There is user training, the trainer training, and support material in print and digital format. If you have any questions on these, they are available on our website, or you can also just contact me. I think it's good for the industry as a whole to also provide, for example, the questionnaires, that they are standardized in such a way that outcomes can be compared also between exoskeletons for the same purpose. So, for example, the amount of support that is provided by the exoskeletons, everybody reports in a different way of that, and that makes it very hard for end users and customers to just select which exoskeleton would be good for them. So some concerns of evaluation from our practice that getting used to, I already mentioned, but it's really fundamental. So end users need time to get used to the products. It's just as learning to bike or getting new shoes. You have to start the first day maybe for 1 hour, then the second day 2 hours, etc., etc., before you can actually have sensible data about if the product is good for you or not. So basically, the expectation is that you can do everything the way you already done it, and then just start using the exoskeleton. But of course, You need to wear it, you need to don it. There's all small things that you need to take into account. If you start using the product too fast and you get irritated, for example, some red skin, well, you need really time to start over again with getting used to it. So it's the same as with your shoes. If you have a shoe and you get a red spot from wearing it too long for the first day, then you have to put it aside for 2-3 weeks, and then you can start over. So this is really important. The experience is greatly dependent on the awareness of the user, and with that, I try to say that some users are very aware about the issue of back problems, for example, because they have back pain. So they have this intrinsic motivation to use the exoskeleton, or they have shoulder pain, or they are fatigued, they cannot do their job. Then they are very aware of the problem that the exoskeleton is solving. But for many applications, exoskeletons are used as preventive device for people that are still healthy, so they are not so aware of the problem that they are the risk that they are subjected to. So we also have to communicate not only this is our exoskeleton, but also the why are you wearing that, and keep doing that. And then ticking all the boxes for the specific environment and users. We've seen in the pictures, for example, the dirty shoulder exoskeleton of Skelex in the previous presentation. And these are all blocking requirements. Everything has ticked the box. You need to be, exoskeletons need to be the right size. They need to be resistant to dust, to rain, to heat, to cold. It could be very different for every different user or different environment. And the last one is team spirit and culture. Customers that are going to apply the exoskeleton really have different cultures, and this makes a huge impact. For example, if the company has the mission to become the healthiest company of the world, something like that, they will have a completely different way of looking at the exoskeleton than if they just want to earn as much money as they can today. So it's a completely different way of viewing the world, and it makes a big difference in how the exoskeleton can be implemented, or if it will be a success. Learning, so targeted use. So the expectation sometimes is that an exoskeleton can be used for 8 hours per day, every day. And sometimes it can, but it's not always necessary. Often there are specific tasks that are very challenging for people. And if you can just support these tasks, it can have a huge effect on the way they experience their job. And in the end, how much risk there is, for example, on MSDs. Committing all stakeholders takes a lot of time, but it's very important to, of course, start with the end user, but you also need the support of the floor manager, the health and safety manager, the C-level, so the top managers, etc., to make a long-term success out of something as implementing exoskeleton. EMG on the work floor is hard. I have a separate slide on that, just to show you what's practice. Setting expectations is already mentioned by me, and I would just want to stress again, all users are different, so you really need to go to the end user and know what their problems are and what their objectives are. So here's a slide about EMGs. We don't have to read it, but we see it in practice a lot that people just put some EMG stickers on some muscles and hope to get out good results from the skeleton. And actually, it's very difficult, especially for back muscles, because back muscles are highly nonlinear, which means that a small change in posture makes a huge difference in the kind of EMGs you get back. And this EMG is not directly proportional to the amount of back muscle exertion. So to do it well, you have to do a full kinematic analysis with the model, as you see on the right of that. But just be careful, because for us it's a real problem if somebody does a study like on the left side, just putting some differences, some stickers at the back, and then the outcome is, in this case, it was no, we don't see any difference. Then for us it's the end of the story. While if you look to this person, you can clearly see the difference in how relaxed he is doing the work, how relaxed the shoulder is, how relaxed the neck is. So he's relaxing the body and using that posture change that he can do because of the support. So this basically was my story. Help is around the corner. In this case, we work through distributors a lot, so we try to support all our customers with the right support worldwide as good as we can. There you can look at our website, but you can always contact me in two ways. Just send me an email. I'm not very good often at my email. You can also phone me or contact me at LinkedIn. So that basically sums up my presentation. Thank you for your attention, and I'm happy to answer your questions.
Thank you very much, Boudewijn. So we're a bit late, but I think we have at least 15 to 20 minutes left for discussion. Already some discussion has been already active in the chat. I try to identify which are the main topics. And I think there is one that has not been addressed so far. You always say that all these research and tests that can improve the design and development of the exoskeleton, but I don't really, I never see an example or whether you actually do it or you do kind of trial and error, or is that kind of procedure or strategy to really make the test and then take the outcome of the test and then make an improvement. So my question is maybe more to Boudewijn. So how did you get to this 2.57 version? How did you take into account the feedback of the customer, or also the metrics and tests that you did?
That's a very good question. So at the beginning of the development of our product, we also made focus group with a lot of different professional, occupational therapists, end users, managers, and just work together towards the first exoskeleton. When we put that in the market, then you really start running into different problems. So it's a good product. It supports the back. We know it does what it has to do, but we are starting to run in different problems when you start implementing it on the work floor. And then we started to work more in a cyclic way, getting this user feedback and going from version to version. Of course, we are currently also working on our next version. And one of the things that is in development, you see it with the German bionics, with the Verve, but also with the strong arm, is these sensor systems that are coupled to the exoskeleton. And I think it's a really good thing that is into development, because it will allow us to collect long-term data in a larger quantities that will, I guess, in the end prove the long-term effects, in a sense, of exoskeletons in practice. But it's a very complex question, because there is no exoskeleton that already proved long-term effects at first, or because there's not enough exoskeletons that are actually used for a long time. And we are happy that we have a lot of users that are using our exoskeletons for many years already. Some users are already using the exoskeletons on a daily or weekly basis for more than 5 years. So we go back to them, we interview them, and from all that feedback, we make our new versions. But it's always too slow, you know. The ideas we have are much better than what we already have in the market, just also because of standardization. Our current product is CE certified as a medical device. It takes a lot of effort just to make a small change.
Yes, actually there was a question on this certification and standardization of benchmarking process, which are very slow, and the technology can take over once the standards are are not aligned with this fast pace of development, which is of course a problem. I think there is no clear solution for this because standards are standards and they need time to develop. So very interesting what you say about these sensors and this long-term effect. I think this is one of the other topics that is really coming out from this discussion. You cannot ask someone to make the test the first day it wears anything. And this comes to another question that is, what is the role of lab tests? So I'm a great supporter of benchmarking and doing test labs, but I'm also asking myself when to do this and whether these tests can predict maybe the performance, real-world performance, or provide a more quantitative observation. But when should this test be done, and what do you all think that are the sensors that are most reliable, useful to demonstrate the performance?
Yeah, it's a very good question. Well, let me first stress that to decide to use the exoskeleton, we have the end user, and the end user is in most cases very just emotional, just wants to do their job, and it's very subjective. Okay, so this is our main sensor is the end user and doing these interviews. But in the decision to use exoskeletons, certainly if we're talking about this wide industry-wide exception, for example, in the automotive industry and in Spain, then there's many decision-making units. And they all need to be comfortable about using the product. So for a health and safety officer, it's very important to see that there is actually a reduction of these stresses in the back before we start using the product, because otherwise they will say, okay, why would I even try it? I don't see it. So the lab tests are very important, both in development, but also as a scientific base on which we build and can start in these companies. So for many companies at the end, the ROI, so the business case for the company is important. And it's of course the outcome of the business case is dependent on many factors, but the most important factor is the effect of the exoskeleton. Does it support the back? Will it reduce back pain, or will it improve this productivity? And the lab tests are very important for that.
Okay, I know that Saskia is here. I see her. Hi, Saskia.
Yes. Hi.
Thank you for
I hope
your
my connection is good enough. I hope my connection is good enough. Do you hear me?
Yes. We use.
So I can add up something on that what Boudewijn just said.
Of course.
Just as an example, because we did the study with the plasterers, and we actually did a study in the lab, or kind of a standardized environment where people were just doing plastering tasks, and we wanted to see, is the exoskeleton effective? So we measured only EMG and I wanted to see, does it actually reduce the EMG activity in the shoulder muscles? And after that study, we saw there is an effect of the exoskeleton, and only then we went into the field, and now we're checking the use of the exoskeleton and the acceptance of the exoskeleton during a full period of 6 weeks. So that would be a good example of, first you check, is there an effect of the exoskeleton during these tasks? And if you see it is effective, you can check, okay, do they actually accept this effective exoskeleton in the environment?
That's very, very smart. So go, no go thing, no? So kind of, yes, preliminary tests. And then maybe go back to the lab after familiarization, or say learning curve, no, of the user, and then go back to the lab. Would you recommend this?
I don't know if I would go back to the lab, because you checked already whether it's effective, and if you know you have an effective device that can help somebody to reduce their load on the shoulder muscles, and you see that they would accept it in the working environment, then I would say I would use it over a longer period of time and see, do they still use it after half a year or something.
That's and so So would you even not recommend using sensors day by day? So sensor in
if you have sensors, if you have sensors in the exoskeleton, which we don't have yet, but if you do have that, then I would definitely recommend doing that. Yes, that would be a perfect next step to do that in the working environment, to see, does it change anything? Does it change the behavior of the people? Does it change the loading on the back, whatever. But so if you have sensors, I would definitely do that.
So kinematics and force pressures, basically. These are the measurements.
There are many different ways of thinking about that. Oh, sorry. So, for example, from our user's perspective, it would be very good to collect EMGs and kinematics, force plates, etc. But I think it's good to have separate systems. Just go back to the user after 6 months and reapply that. The question, of course, is what can we put, from my perspective, is what can we add to the exoskeleton that also gives value to the end user. For example, we have users using the exoskeleton for many years that they cannot do the job without the exoskeleton, but because of the exoskeleton, they can do their job again. For them, there's no question about the effect. Yeah. But it's interesting. I don't know any study about long-term users that went back to the lab and, for example, measured their metabolic rate compared to when they were just starting, because metabolic rate is very dependent on how much you've trained it. How much do you trust the system? How easy is it for you to? So it's really.
I have another question, which is, let's imagine already now, but let's imagine in 10 years you have 10 similar exoskeleton technologies as mobile phones today, and the user has to pick one of these according to his or her needs. So it comes not just a matter of proving that exoskeleton is effective, but it's a matter of choosing, comparing, and matching this with your user needs. Maybe you're already facing this because there are some competitors in the market, no? What kind of what can we do now from the testing, benchmarking, or even communication? No, what can we do to help the user choose the right solution or comparing existing solutions?
So the low-hanging fruit there is just very simple. What's the support torque, for example, for exoskeletons that they support? It's very, very diffuse, and everybody's reporting that in different ways. To translate it for the end user, because they don't know what the Newton meter is, for example. But from a research perspective, and for a lot of health and safety officers or other high educated people, it would be very beneficial just to see all these different support forces. Another aspect could be all these blocking requirements. I think the French did research to that. So, for example, can I use it outside? Yes or no? It will give immediately maybe a selection criteria for a specific exoskeletons. So,
do you think there is already a standardized way to do these things, or each manufacturer consider the aspects that? Do you foresee a kind of standardized, list?
We have to go there. We have to go there as an industry for wider acceptance and adoption of the exoskeletons. And in the long run, if there will be, it could be imaginable, I don't know, but it could be imaginable that for certain jobs that are very taxing, that someday they will say, well, if you're doing this very taxing job, then you will need to wear an exoskeleton to protect your back. So it will be obliged. So if it becomes mandatory and there will be a legal framework, then there needs to be very comparable data and qualification. Otherwise, that will not happen. But that's far in the future. But I think it will go there and grow there. On the other hand, we're just starting to use exoskeletons. So, for example, if you listen to the work of the question before, when we are developing an exoskeleton, we're very focused on the support it's giving, but in practice, it's often the fit and if it's comfortable and where can I hang it, and it's all other things are more important. So we're just learning what is important. So this week or a few weeks ago, there was a new paper about the mental burden of starting to wear an exoskeleton. Okay, it's new information. We have to work that as an industry to see how we can support there, or what's in the end real success factors.
Thank you. Maybe the audience wants also to raise any question if they didn't write. If so, please, this is a moment.
Diego, I just like to comment on one thing, and that is basically when you speak about the lab test. I think that for the development of an exoskeleton, during the development phase, lab test is a very important part. Okay, once you reach to a market, I think after that point, I think we should at least consider the benchmarking aspect, because if you can see that if you have some benchmark or like facilities where you can actually test them, then actually you can still do a controlled environment, because benchmarking is not actually in the industry but outside, perform some very specific amount of tests outside the lab and on the use case, more closer to the use case, which actually can give you much better results in terms of acceptance. And on the other side, I think benchmarking could also provide a long-term data collection aspect as well, which is somehow infeasible to stop the production in the production lines, to perform those type of testing. So I think benchmarking is a very big contributor in that sense.
Yeah, thank you to raise this point, actually, because I totally agree that benchmarking is not just a way to, when the product is finished, to compare, to sell, to better convey the information to the client, to the customer, but also for the developer, even the researcher, to set the goals first. So all this list of items, you should, as a designer, maybe start with say, okay, this is my priority. These are my 5 characteristics I want to achieve. And based on these, I can start identify which are the tests, which are the metrics that I need to reach, and then design to that purpose. Because many times it happens that you just make a back support exoskeleton, make a hip, and then after you created this, now what should I say? So typical user-centered approach, but let's say, of course, if you don't have very specific goals from the very beginning, you just make a new mechatronic device, a new mechanical design, and that's it. But setting these goals from the very beginning, I think, would be a good contributor, because I still feel that the process of designing, test, improving is not very well, really, I would say not standardized, but not very well understood. This is my perception. Okay, so the time is over. If there are no other questions, I would like to really thank the speakers and the attendees for staying here instead of staying in the beach. And I hope that you will join the next webinar, which is on August 24, which is on medical systems. So similar discussion of today, but with medical system that have many other constraints like regulation, medical device regulation, and patients in the loop, which is a big issue. So thank you very much, and enjoy the next month, and stay with us also next time.